A tidal wave is a shallow water wave caused by the gravitational interactions between the sun, moon, and earth. It was used in earlier times to describe what we now call a tsunami. A tsunami is an ocean wave triggered by large earthquakes that occur near or under the ocean.
Some advantages of tidal waves are a highly predictable energy source, high energy density, operational and maintenance costs are low, and an inexhaustible source of energy. Some disadvantages are high upfront costs. One cost of using tides for energy is the construction of turbines and barrages, which can be extremely costly. Due to the density of the water, constructing a turbine that is sturdier than wind turbines requires a lot of technology.
The sources are used in two of the world's largest tidal power stations, our barrages in South Korea and France, with 254 milliwatts and 240 milliwatts electricity generation capacity, respectively. The next largest is in Canada, has much lower generation capacity at 20 milliwatts. Tidal streams. For most tidal energy generators, turbines are placed in tidal streams. A tidal stream is a fast-flowing body of water created by tides. A turbine is a machine that takes energy from a flow of fluid. That fluid can be air, wind, or liquid water. Tidal lagoons is the final type of tidal energy generator, which involves the construction of tidal lagoons. A tidal lagoon is a body of ocean water that is partly enclosed by a natural or man-made barrier. Tidal lagoons might also be estuaries and have fresh water emptying into them.
When this water turns a turbine drive generator, it is transformed into electrical energy. Earth's tides are a vast natural source of power and one of the world's 300,000 gigawatts of tidal power. It is estimated that between 120 and 400 gigawatts could be captured. Tidal energy basics. Tidal energy is one of the oldest forms of renewable energy. It is created by harnessing the movement of waves due to tides, waves, and ocean currents. Turbines placed underwater convert this energy into electricity at tidal power plants. Gravitational forces and tides. Tides result from the gravitational forces of the sun and the moon. Tidal energy is obtained from changing sea levels, both during low tide and high tide. There are two theories for converting tides into power. Horizontal movement of water generates electricity. Energy is produced from the rise and fall of water levels. Historical significance. Tidal energy has been known to humans since around 787 AD. Undersea tidal turbines and tidal barrages are used to harness energy from undersea currents. Geographical constraints. Tidal energy production is influenced by geography, speed, volume of currents. It occurs in specific locations worldwide due to these constraints.
While tidal energy is eco-friendly, it can impact wildlife habitats. Turbines may alter ecosystems and displace habitats in specific regions. Its advances. Tidal energy is renewable, available 24/7 and reduces dependence on fossil fuels. It uses similar technology to hydroelectric power plants. Predictable tidal currents make energy production more reliable. Fun facts for kids. Tidal energy is used to produce electricity and other forms of power. It's a non-polluting and reliable energy source. No fuel is required for tidal energy production, making it economically beneficial.
People in Europe first used tidal energy to operate grain mills more than 1,000 years ago. Incoming tide water was retained in storage ponds, and the outgoing tidal movement was used to turn water wheels to mill grain. This process of using falling water and spinning turbines to create electricity was introduced in the 19th century.